Welcome to a new episode on my series on Unity's HD render pipeline. So this time we're going to take a look at how to implement a basic day and night cycle for your game. I'm just going to continue with my scene here, which we've built in the previous 3 episodes. If you want, you can check them out. It explains how to do the basic setup, how to add a character, and how to add these wind effects. But you can also start from scratch, so the minimal requirements for this tutorial is that you have a basic sky configured using a physically based sky as well as a fog. Alright, so let's get started. So the core component for our day and night cycle is first the physically based sky component, which is basically a procedural skybox which generates the sky according to certain physically realistic values that you can define here. These include things like sea level, planet rotation, fog, and of course, most importantly, the position of the sun. So this is the second important component, the sun, which is just a directional light. So the rotation of the sun directly influences this physically based sky component in terms of color of horizon, for instance, and so on. So if we can just try it, if we rotate our sun on the x-axis, then we can see we can already simulate a sunset, for instance, or sunrise. So here we can see the color of the horizon and the ground color and so on change. So this is all due to our physically based sky component. It's also noteworthy that the actual position of the sun is not important at all. So just like with regular directional lights, it doesn't matter where it is placed. The only thing that matters is the actual rotation here. Okay, so another thing to consider is the celestial body component, which has also just been added a few versions ago, so it's still in preview as it says here. So the celestial body is just a visual representation of the sun, but we can better see it here with the flare size. So this defines the size of our sun object, and the fall off defines this fade value here. So I was actually satisfied with these values, 6 for size and 4 for fall off. And you can define several other values like tint and so on, but we'll just leave it. Alright, so let's start with our simulation of the day-night cycle. Let's actually start with just the day cycle. So what we want to do basically is we want to just rotate our sun along the x-axis. And this basically already gives us all of the effects we want for simulating the time of day. So if the sun has an x rotation of 0, let's say this is the sunset, and then as the day progresses, we'll just increase this value. Like if we have around 90, it should be high noon, yes. And then if we go further and further, the sun starts to set here until it disappears on the horizon here, yeah. And then essentially, we'll just continue to rotate it until it again starts over, and this basically covers the entire night cycle then. If you have issues with performance when you're doing these rotations here, then you just have to make sure that in the package manager, if you go to high definition render pipeline here, you should be up to date here. Otherwise just hit update. Because I had an issue that I wasn't on a most recent version and there were severe performance problems when updating the directional light in real time. Okay, so let's continue by adding the script and implementing our day and night cycle simulation. So I'll just create a new script here, call it day cycle controller. And I'll just start by adding a bunch of variables which will define our time of day. So actually let's start with the float time of day, and we want to control the time of day using a slider in the inspector. So we'll add a range annotation attribute here, and this goes from 0 to, let's say, 24 because I want it to correspond to the real life time of day. From a development point of view, it would be easier to have 0, 1, but we can interpolate between these values later anyway. Now let's add a method, call it update time. We'll update the rotation of our sun according to the time of day. So as I said, we want to have a value from 0 to 1, so let's just divide this by the time of day by 24. So essentially 0 is midnight, and 0.5 would be high noon, and everything in between. So we want to have the sun rotation. We'll use a linear interpolation here between two angles. If we have midnight, the sun should essentially be at the very bottom underneath, so it shouldn't shine at all. And at high noon, it should be at very top, so this would be an angle of 90 degrees. And the opposite would be an angle of minus 90 degrees. So if we have a time of day of 0, we want an angle of minus 90 degrees. And if we have a value of 1, we actually want a value of 270 degrees, which is essentially the same, but would be a full rotation. So we'll just lerp between minus 90 and 270 using this alpha value, which is the time of day between 1 and 0. And then we'll just assign this rotation. Oh, okay, I forgot. Obviously, we need a reference to our sun, which is a light component. Let's just call it sun. And then we can update the rotation of this sun component using Boolean.Euler, which allows us to set 3 angles. So sun rotation is the x-axis. And then we have 0 and no, actually, we want to have a fixed y rotation. Let's just go back. It's minus 150. Let's just set this to a constant value. We might change this dynamically later on. All right, so this is the basic rotation of the sun. Now, since we want to have a slider and we want to update it in the editor, as soon as we change the slider, we'll implement the onValidate method, which is called every time that a value is changed in the inspector. And here we just call update time. Now back in the editor, we'll add an empty game object, day controller, whatever, doesn't matter. We'll just add this day cycle controller script here, and we'll add a reference to our sun. And now if we change the slider, we can see that the sun is updating accordingly. So at, let's say, 12 o'clock should be high noon, yes. And if we continue until we have the evening, oh, it's a little bit early maybe, yeah, depending on whether, depending on where you live and what time of year it is. But anyway, we have our sunset at precisely 18, and at midnight the sun is perfectly at the bottom here. Obviously, it would make more sense to have a rotator here, but since that component doesn't exist for the inspector, I think it's good enough to have a slider. So now that we can adjust the time of day using the slider, we actually want to update it automatically. And for that, we'll just increase our time of day in the update method. Let's add another inspector value for orbit speed. Set it to 1. And in the update method, we'll just increase our time of day by the delta time times the orbit speed. And obviously, if we hit midnight or greater than 24 in our case, we'll just reset the time of day to 0. And we also have to call our update time here. Yes, we can see, okay, now it's set a little fast, but we can already see that the sun is updating properly and can observe our little sunset, which is a little fast. Okay, now that we have a day cycle, we obviously also want a night cycle. And for that, we want a moon and we want a little starry sky. So let's start with the moon, which is going to be a directional light just as the sun. However, we need to adjust a few things. So let's just start by duplicating our sun component and rename this to moon. Now we have two stacked suns, which made the scene a lot brighter. First thing you might notice is that you get a bunch of error messages here, which has to do with the fact that we have two shadow casting directional lights, which Unity doesn't like. Or actually, let's completely disable the sun for now. So for our moon component, let's start by adjusting the celestial body component. So the moon is obviously a little bit smaller. Let's do a value of 1 here, and it doesn't have that much of a fall off, so maybe 0 actually. Yes. What we want to change as well is the color temperature, because moonlight is obviously much more cooler temperature tone than sunlight. So let's switch this to completely cold on that scale, 20,000. And this already gives us some sort of night light look. And obviously, one thing that's also very important is the intensity. So the moon is obviously much less intense than the sun. So let's pick a value of 5,000, I guess. Yes, I think that's a good thing. And we can already see that looks kind of like nighttime. Oh yeah, and now since we have currently disabled our sun, we can also hit enable on the shadows again, and then yeah, this looks much better. Now that we have two directional lights, they can coexist at the same time. However, we don't want them to have shadows enabled both at the same time. So we might want to programmatically disable shadows on the moon or on the sun whenever they are not visible. So we'll disable shadows on the sun at nighttime and vice versa. So in our update time, we'll actually update our moon rotation. So the moon should be at the opposite side of the sun at any time. It's obviously not completely realistic in terms of astrophysics, but in our case for the simulation, it's completely sufficient. So we'll just set the moon rotation to be the sun rotation minus 180 degrees. And we'll just basically copy this line, just replace it with the moon. Okay, and we also need another light component for our moon, light reference. And then we'll add another method. I'm calling it check night day transition. And here we make sure that only one shadow caster is enabled at a time. So let's add another helper variable, is night. And if it is night, then we'll check if the moon's rotation along the x-axis, if that is greater than 180 degrees, then we'll disable the moon. So let's add a method start day and start night. So if that's the case, then we'll start a new day. And then we have pretty much the opposite. If it is not night, then we'll check the sun's rotation and we'll start the night if that's the case. Okay, and in start day, we'll basically set this night to false, and we'll disable shadows on the moon and enable shadows on the sun. So there is a variable called shadows at the light component, and here we can set this to an enum of light shadows. So we'll start day, we'll set sun shadows to on, which is soft shadows in our case, and we'll do the opposite for the moon shadows, setting it to none. And let's just do the exact opposite in start night, setting night to true, sun shadows off, moon shadows on. Alright, so obviously we need to call the check night day transition in the update time method, yeah. And now if we change, okay, now we still get some errors, but if we now start to change our slider value, it should be fine. Yes. We don't get any more console errors. So if we are at night, then the moon shadows are enabled, the sun shadows are disabled, and as soon as we hit daytime, it's exactly the opposite, yes. Alright, so one final touch I want to add are the stars in the sky. So for this we'll add a skybox, an additional skybox emission to our physically based sky. So essentially the the physically based sky is procedurally generated, so this completely overrides any skybox which we would define in general. But we have a few options. We can enable a space emission texture, and we could also do the same for the ground emission, which would be this area then. But we want to have a space emission texture. For that, you can take basically any cube maps or HDRI textures you find on the internet with night skies or space settings or whatever. I'll give you a link in the description for the one I used. So essentially, I'll select my star map 4K. I think that's what I was using. And by default, you won't see a lot, so you have to change the space emission multiplier. So it takes a while until you will see anything at all. I think we'll even have to do 1000. Yes, using a value of 1000, you can see this space emission texture essentially has a special blending which makes you only see the bright highlights of the texture. It's not a complete overlay, but this is actually just what we need for our starry sky. So let's set to nighttime. Yeah, I think that looks pretty decent. And now what we want to do is we want to fade this multiplier. We want to fade the stars according to daytime and nighttime. So let's go back to our script. Okay, so in order to change the values of this physically based sky, first add a public reference inspector variable to the volume. You might have to do an import of those using control period, or right click and go to quick actions refactorings. And we want to have using Unity engine rendering. So this volume is the sky volume, which is the carrier of our physically based sky. And then we'll add another variable for physically based sky. You also have to do an import of this, which is this namespace, Unity engine rendering high definition. Let's call it sky. And now in our start, we'll retrieve the reference for the physically based sky using skyvolume.profile.tryGet. And here you can define which component you want to get from the volume, and we want a physically based sky. As the first parameter, you have an out parameter, which in C# is basically a parameter which you pass, but which is also set inside the method you call. So it's just a different way of retrieving the value. And you basically write out and then the name of your variable. In our case, that's the sky. Oh, okay, and now Visual Studio says that this can be simplified. So let's just remove this because the type physically based sky can be inferred by this variable. Okay, and actually we want to do the same line in our onValidate, since inside the editor the start method isn't called, but we still need to get the reference. So let's just add it here, doesn't matter. Okay, and then in our update time, we'll just set the emission, the space emission multiplier value. So space emission multiplier, this is not a float directly, but a min float parameter. So you call .value, and now you can directly set the float. And this is going to be dependent on our alpha value again. So the alpha value is from 0 to 1. However, the space multiplier, so the intensity of our sky, of our stars, is not linear, because for 0 the visibility will be high, and for 1 it will also be high, because those are the two night times. So we'll actually want a curve rather than a linear scale, and for that we'll add another inspector variable, and this is going to be an animation curve. Let's just call it stars curve. And now we can call stars curve dot evaluate alpha. So what this does is it takes the float value, so basically the y value, at the given x value, and the x value is our alpha, so a value from 0 to 1. So now what we need to do is define the curve. That's just a second. So yeah, now we get this component here in the inspector. Now we can define a curve which goes from 0 to 1 on the x-axis, and on the y-axis we can define the intensity of our stars. So basically we want a curve that it is very high at 0 and 1 and completely low, or precisely 0 actually. Yeah, that's at 0.5 we want a value of 0. Okay, kind of like that. We might want to tweak it a little further, but we'll see in a second. Oh, and one more thing. Since we set the multiplier at 1000, we want to multiply this by 1000 again here. Final thing, we have to add a reference to the sky volume, which is the sky and fog volume here. And now, if we change the time of day, we should see the stars start slowly to disappear. Further we go to noon time of day, and they again start to appear if we go further to nighttime. And now we can tweak it a little further, maybe flatten the curve a little bit, add some more keys here, something like that maybe, and maybe another one here. Yeah, you can play around with these values obviously as long as you want. There are still a few stars visible at daytime, but yeah, in general I think it doesn't look too bad. Now let's see what our moon is doing. Okay, it's also doing the correct rotation. And if we go at this point, there is the transition between the moon that is disappearing and the sun that is appearing at the other side. Okay, now let's go back to play mode. And actually before, the orbit speed was a little too high, so let's just set it to 0.5. I think that's a good value to observe our day cycle. And oh, it's still, obviously it's still too fast for a real game. You can, yeah, depending on what kind of game you're making, you will want to set the orbit speed at a very low value, obviously. But now, in order to evaluate it, I think it's good. And now we have sunset, and at the same time our moon should rise here, yes, and our stars should appear. Okay, I think it's obviously a very simple solution. You can add a whole lot more values that you tweak according to the current time of day. Like for instance, you might want to have slightly reddish color tones in the morning, in the early morning, and yeah, whatever values you want, you can basically do all of those things. You can also use these type of animation curves for all kind of values and colors. So yeah, it's really up to you, but that's essentially the basics for a day and night cycle using the HD render pipeline, using the directional lights and the sky, the physically based sky as core components. I hope you'll join next time when we're going to take a look at a lot more, maybe some advanced foliage, I'm not sure yet. But until then, have fun creating and see you.